Hello, my name is Artur Skowroński and I'm Head of Java Kotlin Development at Virtus Lab. In today's webinar, I wanted to talk about what we really mean when we talk about sustainability in the context of software development. I'm a huge fan of ebooks in general. I usually find time to read in the evening when my little daughter goes to bed and the room has only a dim light. As you probably imagine, under such conditions, physical books are not very practical. However, while reading non-fictional ebooks, I discovered an interesting feature of them. They always surprise me when they end. For instance, while reading a pretty popular book about chips, Chip War, which recently made a lot of noise, I only reached 52% and then it ended. Half of this book was just footnotes. In physical books, footnotes are small and take up less space, so they are not so noticeable. But you know what? Nothing has made me realize the importance of footnotes as much as this presentation. The topic of green technologies requires constant references to documents and external sources, because without them it can be terribly trivialized. And many issues in this case are terribly nuanced. So a mechanical approach with a checklist, it's very easy to get burned. Has any one of you implemented the widely known GDPR regulation in your company? I've done it twice. The first time, even before it became widely known, because I worked for a recruitment company that was very affected by GDPR. It was my first project that I led, from which I learned many valuable lessons and experiences. I then understood the spirit, not the letter, that underlies the whole thing. That's why it was a relatively pleasant implementation, because I subconsciously understood why I was doing it, which helped make decisions about which aspects are truly important. However, I have the impression that many companies have not learned this lesson. I still remember the chaos associated with May 2018, when everyone tried to do everything possible to comply with the regulation, so the fine could not be imposed on them. It was therefore associated with such pathologies as combing through the hard drives of old computers and deleting 50 years old employee names from files that no one knew existed before this effort. And that's why I would very much like us to avoid repeating such a situation in the topic of sustainability and focus on real solutions for the real problems. Okay, let's start the discussion on green technologies. So I will start with the basic question. Is it real about reducing carbon dioxide? And here we come to the first simplification. Everyone talks about CO2, but it's just the tip of the iceberg. If we look into all the sources, in fact, the literature on the subject talks about so-called life cycle assessment, which takes into account all possible sources of greenhouse gas emissions, including methane, nitrous oxide, and others. It is important to convert those gases into a single unit of measurement so they can be easily compared. The so-called carbon dioxide equivalent serves as a kind of universal unit of measurement, allowing comparison of the greenhouse potential of various gases. For example, one molecule of methane has 25 times greater greenhouse effect than the same amount of CO2. I mentioned this example to illustrate that it's not just about CO2, but a wider spectrum of gases. As life cycle assessment in practice means taking a broader look on the impact of technologies on the environment, not just through the lenses of CO2. Now, let's move on to what I call transferring environmental impact, or creative accounting. Here, companies try to assign their emissions to others, shifting responsibilities. Take for instance the somehow cliché example of the broadly understood Western countries, which for years exported waste, including nuclear waste, to developing countries. That's why, to normalize this situation, enable a sensible discussion about emissions and responsibility for them, the Greenhouse Gas Protocol was established. It is a standard that helps companies manage and report their greenhouse gas emissions. It is a joint work of the World Resources Institute and the World Business Council for Sustainable Development. The first category, known as Scope 1, refers to emissions directly from sources owned by the company and controlled by it. A simple example is the fumes coming out of the chimneys of a factory owned by the company, or emissions generated by its cars. When most people think of greenhouse gases, they usually think of Scope 1, but that's only part of the whole picture. The second category, Scope 2, is more complex. It concerns emissions arising from the production of electricity, heat or steam that the company purchases and consumes. In other words, it's about the emissions generated to produce electricity. In the context of software companies, this is important because most of the greenhouse emission come from the electricity used to power buildings, offices, or computer equipment. The third category, Scope 3, is the broadest. It includes all other greenhouse gas emissions resulting from the company's economic activity, but coming from sources that company does not control. Examples include emissions related to materials purchased from suppliers, the way customers use the products sold by the company, and even business trips, such as flights. Even if someone travels by train, which is more energy efficient than flying, they still generate Scope 3 emissions. What I've presented to you are universal categories that describe emissions from every type of business. Understanding the three scopes of emissions is crucial for effective management of companies' environmental impact. However, as this webinar focuses on the software industry, let's think about how the three categories of emissions I mentioned apply to our activities, starting with Scope 1. For software companies, this category is of little interest. We rarely generate fumes, of course. There are exceptions like company cars or airplanes, but I think this is not our main area of activity. More important for us is for sure Scope 2, which is related to the electricity we consume. In the IT industry, a large part of the emissions comes from the energy used by laptops, office devices or data centers. This is our main Scope 2. But there's an interesting case related to the use of public clouds. When we move our infrastructure to the cloud, we sort of transfer some of the responsibility for emission to the cloud providers. In such a case, our company may generate very little direct emissions, but significant amount indirectly. Then we have Scope 3, which is particularly important for us. An example here is the mentioned transfer of burdens to cloud providers, where even though we do not generate direct emissions, we contribute to their occurrence indirectly. However, cloud providers often have much more sophisticated methods of carbon reduction than we do in our data center, so this is a beneficial move. Interestingly, in the Scope 3 is also the energy used by users of our product. For example, how much energy a laptop consumes while using our software. As I mentioned earlier, typical software companies do not deal with Scope 1, and our activities are characterized by different types of emissions. So, in the software industry, there is a need for our own standards that better reflect our activities. In response to this specificity of the industry, the Green Software Foundation was established. This organization, which includes large companies such as Microsoft and Siemens, aims to develop standards and practices related to green software. One of the main achievements of this foundation is the development of the software carbon intensity specification, a specification of carbon emission indicators for software industry. It is a method for assessing applications in terms of the impact on the environment and encouraging actions to reduce emissions. Instead of focusing on the total amount of emissions, as is the case with Scope 1, 2 and 3, this specification focuses on emissions indicators. This means that instead of measuring the carbon footprint of the entire car, we analyze fuel consumptions per mile. In the context of software, we consider things like energy consumption by software, emissions related to hardware, and the energy needed for their production. This model allows us to analyze our energy efficiency and work on improving it. For example, we can focus on reducing emissions by choosing locations with a smaller carbon footprint or by using energy more efficiently. It's important to note that this standard is especially useful for companies managing data centers like Google or Microsoft. However, even for software developers, it can be seen as a clear indicator of where to optimize. The Green Software Foundation continues to develop reporting standards. At the end of the last year, for example, it proposed the Impact Framework, allowing companies to transparently present their emissions. But that's not all. W3C, the consortium responsible for standardizing internet technologies such as HTTP protocol and the web in general, has published Web Sustainability Guidelines. This document offers a series of interesting recommendations aimed at reducing the carbon footprint of websites. Key recommendations include the use of content delivery networks and caching to reduce server load and the amount of data transferred. It is also recommended to compress images and optimize files so that pages load faster and require fewer resources to display. Interestingly, many of these practices overlap with well-known techniques for improving websites' performance. W3C also provides other interesting suggestions, such as writing content in a clear and accessible way so that users spend less time browsing pages, which also contributes to reducing emissions. In my opinion, this is a very positive trend for everybody who needs to skim through the internet. To conclude, it's worth mentioning another interesting aspect related to HTTP. There has been a proposal to add a new header in HTTP that could transmit information about the level of emissions associated with a particular request. This shows the web technology is becoming increasingly aware of environmental issues and actively strives to solve them. Moving forward, let's examine cloud computing and its environmental impact, using Google and their approach to carbon neutrality as an example. Google announced its carbon neutrality in 2007 and renewed those commitments in 2018 and 2020. It's important to note that such announcements are often misinterpreted or overinterpreted by the media. In 2007, when Google announced its carbon neutrality, they couldn't generate enough clean energy. Instead, they funded projects to reduce CO2 emissions, such as wind farms, solar installations, purchasing emissions certificates, and executing tree planting. These actions helped offset emissions generated by their data centers. In 2017, Google announced achieving 100% power from renewable energy sources. However, due to the nature of the energy system, they can't completely avoid using coal-generated energy. Instead, they sign contract for enough green energy to cover their data center needs energy consumption. Even if they sometimes use coal energy, the green energy investments help balance this impact. But it's not all. Google plans to achieve carbon-free status by 2030, a significant engineering challenge. It practically means that every hour the data centers will be powered by emission-free energy, even during the night. This requires cooperation with other entities and a lot of investment in energy storage technologies that are not available right now. Summing up, terms like carbon neutral, 100% renewable energy, and carbon-free may sound similar. However, they signify different commitment levels and strategies in CO2 emission reduction. Continuing the webinar, I now address programming languages and their impact on energy consumption. I would like to highlight an interesting document titled Energy Efficiency Across Programming Languages. This popular study focused on evaluating how much electric energy different programming languages consume. The study used a methodology measuring energy consumption by Intel processors while executing various instructions in different programming languages. The key assumption was that faster code execution means less energy consumption. Results showed that faster languages aren't always more energy efficient. Sometimes slower languages can be more economical in energy. Interestingly, Java, often considered a rather slow language, performed very well in this ranking in both speed and energy efficiency. Another finding was that memory usage by programming languages has a minor impact on their carbon footprint. Heavily and lightly loaded memory has similar energy consumption. This study also showed that there is no single language best in terms of energy efficiency. What is more, while this experiment is interesting, it doesn't consider many other important factors influencing programming language choice in practical applications. So, despite the virality of the whole research, it should be regarded more as a curiosity, which is even stated by the original authors. Concluding the lecture, we move to the fascinating topic of machine learning and its environmental impact. We focus there on estimating document that estimate the carbon footprint of Bloom, the model which has 160 billion parameters. According to a paper, considering the total emission well broken down in the original document, creating one iteration of this model consumes as much energy as 40 single-family houses in a year. This super single comparison indeed shows that the scale of energy consumption in AI processes. I will left to you to decide if it's much or not. However, it's good to know how many energy is consumed during single AI model training. Okay. However, we will not stop there, because I want to discuss yet another interesting document predicting that as AI technology develops, energy consumption will start to decrease. Why? Because we have better AI models that consumes less electricity and specialized processors that are created solely for AI calculation, which are much more efficient. Interestingly, using cloud computing also contributes to reducing energy consumption, as data can be processed where energy is cheaper and more readily available. However, a crucial question arises. All this progress depends on technology giants like Google or Amazon. Should we completely trust them handling over control of our data and computation processes? This leads to contemplation of the balance between energy efficiency and control over our own technology landscape as civilization. The world of technology is incredibly complex, and decisions about green technologies have many aspects, from environmental impact to privacy and control issues. This shows how important a holistic approach in technology and its impact on our lives is. Okay, we are wrapping up, so finally I would like to share some thoughts and conclusions. I want to address the topic of optimization. It was once commonly believed that premature optimization is the root of all evil. However, this statement is often misinterpreted. It was more about the importance of good algorithm and solid implementation rather than micro-optimization on the CPU level. It's important that we understand what really lies behind these words. I'm telling you about this because there's one more popular statement that developers' time is more valuable than server time. However, we must not forget that environmental costs. For instance, the chemical industry was much more profitable until the costs associated with wastewater treatment and other environmental aspects were considered. What can we do as software creators? Write more efficient applications. We, as a programmers and software creators, may not have direct influence over the development of data centers or their carbon footprint. But we can minimize resource demand by creating more efficient applications. The last issue I want to address is the so-called Jevons paradox. It states that as something becomes more energy efficient, we often end up using more of it because it becomes cheaper. This is evident in the case of Norway, where the electric cars subsidized system led to an oversaturation of the vehicles in cities, while a more ecological solution would have been the development of public transport. We must be aware that energy optimization does not always lead to emission reduction. In conclusion, I want to thank everyone for their attention. Remember, each of us can impact the environment even through our daily work as creators of software. We just need to be very good and very cautious during that. Thank you very much.